Hello everyone, welcome back to the next video in the guided note series for the Unit P packet. In this one we are solving quadratic equations by factoring first and then setting each factor equal to 0. So when I ask you to solve, I want an answer for what x equals. Just so happens that we're solving quadratics here where everything is raised to the 2. So I'm going to use my product sum. Product of two numbers has to be -12, and the sum has to be -4. We saw a problem like this in the previous video. Let's see, those numbers are 6 and 2 will get me to 4, -4 if I have -6 and +2. There's my factoring, step 1. Step 2 is going to be setting each of those factors equal to 0 and solving for x. So x equals -2 and x equals +6. We'll talk about what that means graphically later on, maybe in this video series, but definitely in the coming chapters. Okay, in 61, it looks a little bit different. The quadratic isn't set equal to 0, but I can recognize that if I subtract 10x from both sides, I move the 10x over, what I get is in fact a quadratic that's set equal to 0. I'm looking for two numbers that multiply to 25 and sum to 10. You are probably already thinking, oh, those two numbers are 5, -5, because -5 times -5 is 25, positive 25, and -5x minus 5x is -10x. And so I've got x minus 5 equals 0, and x minus 5 equals 0. My only solution here is where x equals 5. Okay, you can try 62 on your own, and we are going to move on to talking more about quadratics, but now instead of talking about the numerical or algebraic side of quadratics, we're going to talk about the graphical side and a little bit about the quadratic formula. So you might remember that anything in the x squared family is a parabola that is going to have two roots. Maybe it crosses twice and they're real and rational or irrational. Maybe it only crosses once where that turnaround or touching point is the maximum or minimum, and it only has two roots. For example, in the previous problem where we had x minus 5 squared, or in this case it would be x minus 2 squared, we would only have one root. It would be at the same place. Okay, so how this all ties together algebraically is that if we take this quadratic formula, which is if we take the quadratic equation, ax squared plus bx plus c in standard form, and if we were to solve it for x, in other words, if we were to get x by itself, here is the formula that we would end up with. We would end up with the quadratic formula, which you all probably had to memorize at some point in Algebra 1 or Algebra 2. All it means is that I find a way to find the roots of the equation, where it crosses the x-axis, find the solutions when I can't factor. So this is a way to solve for x when a quadratic equation is not able to be factored. The first thing I have to do is determine the values for a, b, and c. In this case, a is 1, b is 2, and c is 3. I'm going to find the discriminant, which is this part, b squared minus 4ac. This is going to describe the nature of the roots. It's going to tell me if the roots are imaginary, in which case there will be a negative under the radical sign. It's going to tell me if they're real, I will have an answer where whatever's under the radical sign is positive. Let me just erase this. And then it's going to tell me how many roots I have as well. So in this example, we're plugging in negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't have to worry right now about the negative b over 2a. All I'm interested in is this discriminant. Discriminant means it's choosing, right? it's choosing which part of sorry, discriminating and choosing or deciding what the roots are going to be like. It's describing the nature of the roots to you. So in this case, if I plug in -2, so that's negative b plus or minus, negative b plus or minus, and I told you not to use that part, so let me back up a little bit. Okay, what we're going to do is check out the discriminant. So we're going to take the square root of b squared, of 2 squared, minus 4 times the a term, which is 1, times the c term, which is 3. And when we do that, we get the square root of 4 minus 12, which is the square root of -8. When we take the square root of -8, we have to simplify that into the square root of -1, square root of 4, square root of 2, and what I end up with is 2i square roots of 2. What that means is that I have 2 imaginary roots. We will talk a lot more about this, but this is just a review of what you may have talked about in your Algebra 2 class. Okay, I will see you all in the next video.